So the next piece that I'm going to do is actually start solving the homework. So if you want to look at your homework one, now would be a great time to grab it. So the first thing that we're looking at is a question of what's the cross-priced elasticity of demand with respect to Chrysler in Nashville, Tennessee. So I know that the data here is going to be helpful, but I'm going to start with a slightly different approach and see if I can't go through this problem and try to think through what I'm actually doing. So the first step that I have is, what is cross-priced elasticity of demand? So I'm going to write it as the elasticity of the quantity of our minivan when you look at the price of Chrysler is going to equal delta Q delta price of Chrysler times price of Chrysler over Q hat, our minivan. Right? So that's our basic approach. Now, what's great is the change in quantity with respect to change in price is exactly the B hat that we get on price of Chrysler. As you can tell, I don't write Chrysler very often. And what is that B hat? Well, that's what we just did in the regression work, right? So when we look at what's that B hat, it's 3.003, right? So I'm just going to take that value and directly drop it into our equation here. Sorry, and that's still P. I'm just going to shorten it to C since we know I can't spell Chrysler, over Q hat our minivan, right? So now I can drop in that value of 3.003 times P of Chrysler over Q of our minivan, right? So we're still missing two elements, and the first one that we will go for is, let's try to figure out what the price of Chrysler is in that market. Because we're not actually doing a very broad and general approach. We're trying to figure out in Nashville. So you can think of yourself as the auto dealer in Nashville. The overall elasticity, that's interesting, but you actually care about the elasticity in your own market. So we will go back to our data. We'll have to go back to our raw data back at the beginning, and we're talking about Nashville, so we'll look for Nashville. We found it, and one of these columns is going to be the price. Chrysler price is column H, and column H25, that is the number that we're looking for, 19.05. So we're going to take that and drop that back into our model. So this equals 3.003 times 19.05. Sorry, I'm getting a little bit crowded here. Divided by Q hat, our minivan. So we've made some good progress, right? We're pretty much done except for Q hat. So let's go and do Q hat. That's the last piece. So what is Q hat in Nashville, Tennessee? I'm going to hide this just so we can see our data a little bit more easily. We'll leave one example above and hide. So units sold is Q. That's the actual quantity that we sold. What we're interested in is coming up with Q, and for lack of a better word, I will call it hat, or expected Q. So in order to do this, what I'm going to do is drop in an extra column here. That's not what I want to do. Insert an extra row here. Here we go. And I'm going to grab the coefficients from the regression and drop them in here. And we'll see why in just a moment, okay? So I'm going to go back, and here's our nice, clean, cute little example. And ESV E should get us there. Okay, so I'm kind of cheating because this is the A coefficient. It's not really units sold, but we don't have a column, and you all are bright enough to follow that. So if I'm trying to figure out what the actual expected quantity sold, or what did my model tell me we would sell, and I'll do it for Ann Arbor, it says you're going to be able to sell -6 units plus the coefficient times your own price plus the coefficient times income plus the coefficient times population plus the coefficient times percentage under 18 plus the coefficient times Chrysler price plus the coefficient times advertising. So here, the model that we ran, the regression is our model, told us that inside Ann Arbor, we should be producing 52 or selling 52 cars. And actually, that's not bad, right? The units actually sold was 55, 52, 55. That's not wildly different, so our model seems reasonable. That's not a statistical comment. That's just an overall thing. So we can pretty much, with only a small little edit, go through and lock the row reference for all the coefficients. So we'll keep that at 2. We'll keep that at 2. 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 Now, with a bit of luck, we can just run down and copy paste that formula all the way down. And it is still going to be referring to the initial intercept of -6 plus and then those products, the sum of the products. So here we go. The expected number sold in Nashville was 30.5354. So we can flip back to our nice little sheet here, and we're pretty much done. So the elasticity with respect to Qx, comma, P, oh, that was bad show there. Let's get rid of that little x up there and call it Q sub x, so my notation isn't any worse than it has to be, and that is going to equal 3.003 times 19.05 divided by 30.55. So realistically, you're much more likely to do this in Excel, but because I could just go through and grab the actual values in Excel and have it calculated for me. But at least this should give you the intuition and a quick understanding of how it works, and that should be approximately 1.87. So I hope this was helpful to sort of walk through 1A, and you can use that as a model for understanding part B as well. Hi. I wanted to go through homework 1 in a way that would give you an opportunity to review it pretty carefully without taking up too much class time. And I also thought that going through homework 1 will make us go back to the minivan data. Thinking about that, I realized I didn't do the best job of doing a careful review of regressions for this class. So if you wanted a quick refresher, this is here for you. So what you see on the screen is the data that was available off the website for the minivan data, right? So we've got basically a rectangle of data. In the first column, you have the locations. Second column is the zip code that accompanies that location. Next column is sales. And to make things clear, I'm going to change the name of this to units sold. The next column is average price. And I'm going to do a couple shortcuts here. The first one I'm going to do is say, instead of calling it average price, I'm going to call it own price, meaning the price of the minivan on average for that zip code. Income, I'll just shorten it a little bit. Population, shorten it a little bit. Less than 18 is fine. Chrysler price, that's fine, except for the thousands. And advertising, again, pretty much okay. So all I'm doing is making the data a little bit more ready for analysis. Now, in order to map this into something that you may have seen before, what we're going to do is call the units sold our Y variable, right? And basically, we're trying to come up with a model that explains how many units are sold in an area, and we think that's going to be a function of a few different variables. The first one is the product's own price, the price that you're charging on average for that minivan. The second one is going to be the average income in that area. After that, we can think of it as the population in that area, the number of small people who require you to buy a minivan in that area, the price of your competition, and how much money you spend on advertising, right? So the basic idea behind a regression is that we're always going to be looking for something that looks like, so just to write on top, y equals a plus b1 times x1 plus b2 times x2 plus dot 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 plus b, in this case 6 x6 plus some error term, right? That's our general approach towards a regression. And what I've done here is try to set it up so that we're back to that basic formulaic approach, right? I've got my y is equal to a function of these other items. So from here, what we're going to do is actually run the regression. And running a regression is pretty straightforward. You want to make sure that your y and your x's are all adjacent to each other, no gaps. We've got that. So I'm going to go into data, data analysis, scroll down until I see regression, and my y input range, I already labeled it, that's our units sold. Our input range for x is going to be everything else. Right? And if you look, the first row that we've captured in that data, row 2, are labels. So we'll say, please recognize those as labels. Those aren't data. And we're just going to go for the default outputs on everything else. I'm going to ask it to drop it into a new worksheet ply, which I will call raw regression output. Okay. So I'm going to click. Okay. Here we go. This is our raw regression output. So there are lots of things that you learned about in your other course, I hope, about regressions, but we don't need it. What we need is really just this idea of what are the coefficients on the variables that we think matter, because this is our model, right? So we're saying that we think the number of units that you sell is going to be a function of the price that you charge. You'd expect a negative sign because that's law of demand. The income of the population, the wealthier the population, the more people will buy, maybe higher turnover of cars. The more people there are, the more units you can sell. The bigger the percentage of the population that is young, the more units you sell. The higher Chrysler's price goes, the more units you sell. And the more you spend on advertising, the more units you sell. So that's just an extremely straightforward layout, and I'm going to do a quick little change in just a moment, but that's what we're looking for in the regression. So all I've done on this new tab that I called regression results is I've cleaned up that raw regression output a little bit. So all I've kept is the actual coefficients from the regression, which we're seeing in this little table, right? Just a straight copy paste of the old information. And I wanted to map this back into sort of the structure that you probably know, right? Where we're saying y equals an intercept, which we're going to call A, that is your intercept, plus the coefficient on own price minus 5.2 times the price that you're charging in that market for your product, plus 4.5 times the income plus 0.92 times the population plus blah, 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 right? So in order to present this a little bit more cleanly, I'm just going to do a little trick and say round this to 3 decimal points, and you'll see in a moment why. And I'll hide that for, well, why not? Because it's fun to be tricky. And down here, this is the actual equation that you're seeing now. Okay? So y, our expected number of units sold, is going to be a function of minus 6.65 plus a negative 5.2 times own price plus 0.45 times income plus 0.926 times population plus, and we go through each one of the coefficients, right? So all that's telling us is that is the model that the regression is estimated for us. So now we can start actually tackling the data that we saw.